Welcome back, everyone. We are going to continue our discussion on private DNS by now discussing two scenarios for integrating private DNS with an Azure virtual network. Specifically, we are going to further focus on using Azure private DNS zones and also on the more manual customer-supplied DNS server option. In this lesson, we'll start off with the high-level overview of how to implement an Azure private DNS zone, talk about the relationships between virtual networks and private DNS zones, and also discuss the interactions between automatic versus manual DNS registrations in those private DNS zones. We are then going to switch gears and take a closer look at the customer-supplied DNS server option, and there's quite a bit to cover on that. Let's go ahead and jump on into it. So starting off with the high-level overview of how to implement an Azure private DNS zone, which is again the Manage Custom DNS Resolution option within Azure. Overall, the basic implementation process is actually pretty simple. Step 1, we create a private DNS zone within an Azure resource group. This is very similar to how we created a public DNS zone, except once again, it's not public. And then after we create our private DNS zone, we will then link one or more virtual networks to register that virtual network to that private DNS zone, after which the Azure private DNS service will take over private DNS registration entries within that virtual network. Next, let's talk about the relationships between Azure virtual networks and private DNS zones. Few key points to keep in mind. The first is that for registration options, virtual networks can only register to a single private DNS zone. As we will see in our demonstration coming up, once we register our example virtual network to our DNS zone, it cannot register to any other DNS zones. With that in mind, a virtual network can resolve to multiple DNS zones as opposed to registering to only a single one. This means that if we are linking with other virtual networks which have their own private DNS zones, our virtual network, called My VNet in the bottom right, can also use those multiple DNS zones for resolution, even though it is only registered to a single private DNS zone. And finally, keep in mind we can flip around this relationship in which a single private DNS zone can have multiple individual virtual networks registered to that zone as well. So again, just to summarize, a single virtual network can only register to a single private DNS zone. However, a private DNS zone can have multiple other individual virtual networks linked to that zone as well. Next, let's talk about the relationship between the automatic versus manual DNS record registration options available within private zones. As we mentioned earlier, Azure private DNS zones give you the choice of using automatic registration for virtual machines, and you also have the ability to create manual records as well. The interaction or the relationship between these two record types is very important. With Azure private DNS zones, if auto registration is enabled, which is again the default option, all management of those records are, not surprisingly, automatic as well. This means that for new and existing virtual machines, an A record will automatically be created for you, and it will be automatically managed and updated. So if you change the internal IP address for a virtual machine, that record will be automatically changed as well. However, be aware this is only for dynamic IPs. Static IPs will not be automatically registered or changed. And if you remove or delete a virtual machine, that record will automatically be removed as well. Overall, with auto registration, records are automatically added, changed, and deleted on your behalf. With that in mind, though, you also have the ability to mix and match automatic and manual records in a private DNS zone. However, there are some very important considerations that you need to keep in mind. As we mentioned, you can mix and match automatic and manual registrations. However, when you create manual records that have the same name as an automatic record, that manual record will override or replace the existing automatic record and become the only record for that particular resource. And when you do so, you get a warning message on the right side informing you that there is already an auto-registered record in place, and this manual record will override or replace the existing one. Let's say, for example, we want to create a manual record for VM1, which will override that automatic record. The automatic one will disappear, and the manual one is the only one in place. Now, when you're working with manual registrations, you are fully in charge of both the addition, update, and deletion or removal of those records. Compared to automatic registration, IP changes are not automatically reflected in that record. You have to manually change the IP assignment yourself. And if you remove or delete that associated virtual machine, you will be responsible for manually deleting that record as well. Overall, when working with manual records, you are fully responsible for keeping manual records current, accurate, and up to date. It's not going to do it for you. Next, let's move on to our other scenario in which we are working with on-premises DNS resolution, specifically working with customer-supplied DNS servers. In the scenario we want to focus on, we have an on-premises network which is connected to an Azure virtual network through some sort of a hybrid connectivity option that needs to resolve on-premises queries to Azure resources. For example, we may have an on-premises server that communicates with an Azure virtual network over its DNS hostname. For this scenario, we actually have two possible solutions. However, one of those solutions is a managed service that is currently available in public preview. The first solution, and the one that is considered to be correct from an exam perspective, is to create your own DNS server virtual machine in your connected virtual network to handle DNS queries from your on-premises environment into your Azure environment. And the reason this is necessary, as we mentioned before, is that the other Azure managed private DNS solutions do not resolve queries from on-premises into your Azure environment. This is also the solution that we are going to be spending most of our time on, and as of this course's filming, is the correct solution. With that in mind, however, there's also a recently released managed service currently available in public preview called DNS Private Resolver. Again, as of when this course was created, this is currently in public preview. However, it will become generally available at some point in the future, in which it is a newer managed service which replaces the requirement for your own customer managed virtual machine, which is present in Solution 1. With that in mind, let's go ahead and focus on Solution 1, which is our customer-managed DNS server in a connected virtual network for our on-premises DNS queries. Let's go ahead and unpack that scenario now. In our scenario, we have the following setup in which we have a customer network or an on-premises network in the top left, which is connected over a hybrid connectivity option to our virtual network called VNet 1 in the bottom left, which is also connected over a site-to-site VPN connection with VNet 2 in the bottom right. That site-to-site VPN connection could very well be a peering connection as well. In our scenario, we have on-premises network resources that need to query Azure network resources, which first go through the on-premises DNS server. To bridge us over to Azure for Azure-based resolution, our on-premises DNS server will then forward that DNS query request to a DNS server that exists inside of our virtual network. This VNet DNS server is a virtual machine that we are fully in charge of managing, which is typically either an Active Directory server, could be a Unix bind server, or some other server that is able to handle DNS queries. Further unpacking this scenario, this customer-supplied DNS server will also be responsible for managing DNS queries within that virtual network itself, and for queries that go outside of the virtual network to other Azure resources, those queries will then be forwarded to that wire server address of 168.63.129.16. Once again, that IP address is going to come up quite a bit. Further unpacking this scenario, if we need to resolve queries between connected virtual networks, our left side DNS server will send queries to our other virtual network's DNS server and back and forth as well. In other words, DNS queries will be forwarded between virtual networks by those customer-supplied DNS servers. And in our virtual network 2, or VNet 2, the exact same scenario is in play, in which queries within the virtual network are forwarded to our DNS server, and queries outside of our virtual network are once again sent to our wire server address as well. Overall, one very key point to keep in mind is that each virtual network must have their own DNS server in place to resolve queries inside of that virtual network. If we have two virtual networks, we need to have a DNS server inside of each of those individual VNets. Next, I want to very briefly talk about the newly released managed service, again currently available in public preview, called Azure DNS Private Resolver. We're not going to spend a lot of time on this solution because, again, it is currently available in public preview and is not the currently correct exam solution. However, that may change in the future, so we do want to make sure to cover both. From a high level, the Azure DNS Private Resolver service serves the same purpose as our manual solution in providing a customer-provided DNS server. However, since it is a managed solution, it is able to manage that query relationship, or in other words, there is no need to create an additional DNS server virtual machine inside of your virtual network. And from a timing perspective, this service became available after the AZ700 exam was released, so this is a little bit of a change from when the exam first came out. From an exam perspective, the only thing we need to stress about this specific service, at least for this current point of time, is that we do need to be familiar with each of our different managed and unmanaged solutions. As of this very moment, when this course was released, the current exam will test on the customer managed virtual machine solution, in other words, the one from the previous slide. However, it is always possible when this service does become generally available, this may change in the future, in which case we will, of course, update this course as necessary. However, for the moment, just be aware that this new managed service does exist, which provides a managed alternative to setting up your own DNS server virtual machine inside of your virtual network. With that, that will conclude our second conceptual overview of working with private DNS on Azure. Our next lesson is going to be a demonstration of implementing an Azure private DNS zone. For now, let's review our key takeaways before we move on. We covered quite a bit in this lesson. We started off by learning the high-level overview of how to implement Azure private DNS zones, which is a basic two-step process of creating your zone and then linking your one or more virtual networks to that zone. We then discussed the relationship between virtual networks and private DNS zones, in which virtual networks can only register to a single DNS zone. However, they can link to other DNS zones for resolution, and the reverse is true, in which a single private DNS zone can register with multiple virtual networks. We then talked about the relationship between automatic and manual registrations, in which auto registration essentially handles everything for you. By comparison, though, manual registration overrides auto registration, and you are fully in charge of keeping those manual records up to date. And we finish things up by covering our on-premises DNS scenario, in which we focus on our non-managed solution, which is again the current accepted solution, in which we had to create a DNS server inside of our virtual network, from which our on-premises DNS server will then forward requests to our customer-supplied virtual network DNS server in each of our individual virtual networks. That's going to go ahead and wrap up this lesson. Let's go ahead and move on to the next one.